back. So today we're going to go over writing equations for parallel and perpendicular lines. So we did this actually in the last lesson in Unit 4 because we wanted to get a jump start on the game, right? But when we're writing these equations, things you should know about parallel lines. Parallel lines have the same slope. That means if this is equation 1 is y equals 3x plus 8. Equation 2 is y equals 3x minus 4. So we call it equation 1, equation 2. We can write a statement about these two equations. The slope of equation 1 is m1, it's 3. The slope of equation 2 is 3. We can write a statement that says if m1 equals m2, so the same, I'm going to make a little note, these are the same, then y1 is parallel to y2. That's our conclusion. Those are the facts. Now, similarly, for perpendicular lines, they have slopes that are opposite reciprocals. So let's first look at what opposite reciprocals look like. So opposite reciprocals, let's say I have a number, right? Well, its opposite reciprocal, I have a number, let's say we're going to do a couple numbers here. Okay, and we're talking about slopes here, right? Well, if I have 2, -1, 1/2, 3/5, and 0, and let's pick one more. Let's say -7/8. Well, first, we're looking for numbers that are the opposite, right? And then the reciprocal. So the opposite of 2 is negative, and the reciprocal is 1 divided by 2. Now the opposite of -1 is positive, and the reciprocal is just 1. Okay, the opposite of 2/1 is positive. No, 2/1 is negative, and the reciprocal is 2. So all we're doing is just flipping it over. The opposite of the positive is negative. The reciprocal is 5/3. Now this is one is special. So the reciprocal of 0 is undefined, and this is positive, and 8/7. Now, for the next section, you are writing the equations of the line that's parallel to the given slope and a point that the new line runs through. So I'm not going to read through the directions, I'm just going to go right at it. So when we're setting this up, we have our old slope, old m, new m, points, and b equals y minus mx. So several things. This is from our last unit. This is the setup. The only difference is, the only thing we're adding that's new is the new slope. We're getting the equation of a new line, right? Of a line in particular that's parallel. So my slope is -3. My new slope is -3. The point that it runs to, x comma y, is 4 and 5. That implies that b is, if I plug these numbers in, let's see, 5 minus -3 parentheses 4. This equals -17, or positive 17. My equation is y equals -3x plus 17. And we are not going to graph this equation because you can't graph it on this particular graph. So we're going to just Skip graphing that. Okay? But my new equation is y equals negative 3x plus 17. So looking at it algebraically, the old slope is negative 3, my new slope is negative 3. The lines are parallel. Okay? So if you wanted to graph this line, you could go right 4 up 5, right 4 up 5. Use the rise over run. Sorry, my screen's a little off there, so let me calibrate it. Using rise over run form, right 4 up 5. Using rise over run form, we can go down 3, right 1, and make a point. Up 3, left 1, and make a point. And my line looks something like this. This is the actual equation here. Y equals negative 3x plus 17. Okay. Next one, same setup. We have old slope, or old m. And here it's 2. We have the new slope. They were looking at same slopes here, so it's 2. X and y. X and y are 3, 6. 3 and 6. And I can go ahead and graph this line. So I'm going to find 3, right 3, up 6. Here's the point. And I go up 1, up 2, right 1, up 2, right 1. And I make my line. That's the equation. That's the equation. Okay? Now, for b equaling y minus mx, this equals 6 minus 2 times 3, or just 0. My equation is y equals 2x. That's my final equation. Now, for x equals 4, my old slope, my old m, is undefined. My new m is undefined. It's the same thing. Now, x equals 4. I'm sorry. X equals 3. My bad. Now, x equals 3. Y equals 5. All right. Now, if my old slope is undefined and my new slope is undefined, that implies that I have a vertical line equation. I have x equals 3. So my new equation is right here. My new equation, the graph of this equation, is at x equals 3. Okay? Next, writing equations of lines that are perpendicular. So it's similar setup. The only difference is our new slope, the new m, is going to be the opposite reciprocal. If our old slope, if the old m is 2, then our new slope is going to be negative 1/2. New m, okay? And we're going to use that information in combination with finding a y-intercept to write the equation of a line. So, old m, new m, x, y, and b. Okay? So old m equals negative 3. New m is going to be the opposite reciprocal. These lines are perpendicular, so plus 1/3. The x value and the y value, 4 and 5, and make sure that's accurate, and it is. That means equals y 5 minus 1/3 times 4, or let's see, 15 over 3 minus 4 over 3. This equals 11 over 3. My equation that's perpendicular to that is y equals 1/3 x plus 11 thirds. And try to setting up the next one on your own. Find the old slope, the new slope. Let's write this down. We're looking for the old slope, old m, new m. These are perpendicular, remember. X, y, and b. The old m, if you haven't done it already, is 2. New slope is perpendicular, so it's opposite reciprocal. Lines are perpendicular, so the slopes are opposite reciprocal. So negative 1 over 2. X equals 3. Y equals 6. B equals y minus mx. This equals 6 minus negative 1/2 parentheses 3. Or 6 minus, let's see, 3 over 2, or plus 3 over 2, right? And you get 15 over 2, so y equals negative 1/2 x plus 15 over 2. Now, my next line that's perpendicular is it's a curious type of problem. Now, my new slope, I don't know yet, but my old slope, my old m, it's x equals 4, is undefined. If you remember at the beginning, the opposite of undefined, the opposite reciprocal of undefined is 0. X equals 3, y equals 5, b equals y minus mx, or 5 minus 0 times 3, or just equals 5. So your new equation is y equals 5, and you're done. Okay? Relatively short lesson there. Now, going through the next part, it says the equation x equals 5 is a vertical line. The equation means that the line goes through the x-axis at 5. A vertical line will go through the x-axis, not the horizontal line. The equation y equals 2 is a horizontal line. The equation means that the line goes through the y-axis at 2. Notice in horizontal and vertical line equations, there is only one letter. If you ever see an equation of a line with only one variable, you know right away that is either vertical or horizontal. The slope of all horizontal lines is 0. The reason for this is that horizontal lines would have 0 in the numerator, which is always 0. 0 divided by 5 equals 0. The slope of all vertical lines is undefined. The reason for this is that vertical lines have 0 in the denominator, which is always undefined. Okay, so 5, any number divided by 0 is undefined. So what we're going to do is we're going to either, if it's x equals a number, we're going to go to the x-axis and find that number and make a vertical line. If it's y equals a number, we're going to go to the y-axis, find that number, and create a horizontal line. So x equals a number, my slope is undefined. The line is vertical. So go to x equals 3, create my line. For y equals number, my slope equals 0. This is a horizontal line. Okay, so I go to the y-axis, find -1, create my horizontal line. Now I'm only going to do number 3, up to number 3, but it's expected that you finish the rest of them for homework. So y equals 6, I go to where y equals 6. Let's see, 1, 2, 3, 4, 5, 6. And this is a horizontal line. Horizontal lines have a slope of 0. So I'm just labeling a couple things. I write what the slope is, I graph the equation, and I write whether the line is horizontal or not, or vertical. So please do 4, 5, 6, 7, 8, 9, 10. Make sure we have any more there. 11, 12, and 13 for homework. That's what I'm counting for homework 1. You guys have done a good job. Have a good day. Thank you for watching the video. You are the best. You're my favorites.